My talk is about JS maps and their APIs. I will talk about what's kind of essential to hack maps on the web. My talk wouldn't be that mind-blowing as Vladimir's. It will be more hands-on. We will do some demos. We will try to Google stuff maybe as well. And I will tell you much more. So, my name is Pavel Zbytovský. I work at kiwi.com, which is the organizer of this event. And I think we do really cool stuff with front-end development. We use React, server-side rendering, and GraphQL everywhere we can. And I'm really excited to work at Kiwi, and I also would be glad to work with anybody who like this tech stack. Also, I'm a map enthusiast. That means I'm active in the OpenStreetMap community for almost 10 years. And I've already done some thesis, like bachelor thesis and diploma thesis on this topic, and I helped develop this portal, which you can find on this website, and I will tell you more about it in a moment. Well, so maps on the web. How can we do it? It's easy, right? We can just take Google Maps and everything works. It's really pretty fast and pretty covered. But as Vladimir already mentioned, they have, well, some, like 8 years ago, they completely killed the free version and started a paid version. And now, just 1 year ago, or what was it, they make it much more expensive. So we have to look for different options. It works, but it's costs. I will show you the comparison of pricing later. Well, let's explore the topic very deeply. We will talk about how raster tiles work, a little something about projection, because it could be useful to know it. There is this Mercator projection, which is used kind of everywhere, also for vector tiles. Vladimir already mentioned protocol buffer tiles, which are these Mapbox vector tiles, MVT files, and we will also talk about coordinations a little. We will compare several JavaScript maps libraries, or framework if you want to call them. We will compare the pricing, and also we will explore some additional services and do some demo. Also, I'm an enthusiast in the OpenStreetMap platform, so I will tell you a little more about it. Now I would like to ask who in this among you has already used Google Maps on website. Can you raise hands? Okay, almost everybody. Who has used Leaflet.js? Also, almost everybody. And has anybody used Mapbox.gl? Also many people. Okay, cool. So you are maybe familiar with the concepts, but let's see if there is something more you can find about it. And also, is there anybody who has edited OpenStreetMap? Yeah, just few people, but also some. Okay. Well, you know that 90% times you just need this Slippy map. This is called Slippy map, maybe in some slang, but it is this simple map. Usually it is used with raster tiles. So I will show you how it works inside. So let's see how it works in presentation mode. Well, I would like to show you how the map tiles work inside this leaflet window. So we will open developer toolbar. And we see, you don't see him. You can see map div over there, which includes the tile pane, which has all the different images, and these are the tiles. I will tell you more about it. We will just copy the URL and see how it works. Here. So this is the single tile. You have probably heard about it. In Google Maps, it works really the same. You can try it yourself as a homework. But, well, there is one difference, and that the URL is not that clear as this one. I will show you on the slide. Well, so this technology is called quad tiles. It means that the Earth is, well, spherical. Some people hope it's flat, but it's really spherical. And it's like turned into cylinder. And it's not just cylinder, but it will be good like this. What does it mean for the North Pole and South Pole? Can anybody tell? What happens to South Pole or no, North Pole? Sorry? Yeah, it's a line. It's the North Pole turns to a line which is as long as the equator, the middle line on Earth. I'm not sure on the pronunciation. So this really makes the Earth looks different, and only sizes which are really okay are the one which are in the middle, and everything which is in the top seems bigger than it is. So if you think that Africa is really big, in fact it's even bigger. So we have these zoom levels. First we have zoom level number 1. Which has like 4 tiles, and with every zoom level it splits into another quad tiles. That's the name. Well, there's another illustration which comes from the Leaflet.js documentation. You can look it up on this site, and this also shows that the width of the tiles is 2 to the power of the zoom level. So in the zoom level number 0, we have just 1 tile, and so on. Well, now we can hack at the tiles a little. As you can see, this is the URL of tiles on the OpenStreetMap website. And if we open it, let's see what happens. Nothing, because this Z, X, Y are just placeholders. But we can hack it really easily if we do just this. We should see the whole Earth. I haven't tested. Oh yeah, it works. And it works also with the other levels, of course. Let's try it with zoom level number 13. Can you guess what is the number of tiles in zoom level number 13? Can anybody count it or tell it? Yeah, 2 to the power of 13. So any suggestions? What is the number? Any mathematicians here? It's something like 8,000. So if we open this tile, which you can't see the numbers very clearly. This is tile number 4,000 and 2,000 on the zoom level of 13. So you see that it's on Smíchov, and this is the X. So if you want to move right to see the old town, we can probably just write 4 here, but I'm not sure if it will work. And it works. Okay, great. So this is hacking of tiles. It's not that mandatory to know it, but sometimes it's useful. Also, we had this different tile. Yeah, we will see it later. Okay. This is just a short note that the Mercator projection is not really cylindrical. It's kind of distorted in the top, but it's just for interesting topic. Okay, still on a raster tiles, we can do some overlays, which is in the leaflet library. We can easily add some markers, points of interest, roads, GeoJSON, and stuff like this. I don't want to cover the whole documentation, but let's just see maybe something here. I will move it. If you Google for Google Maps.js, yeah, you will find examples, and there are many of them. Somewhere here is like simple marker. So this marker is just programmatically added, and you can add as many as you want, but it won't perform very good, of course. I will also show you our portal website, which has some other illustration what can be done with raster maps. For example, you can add the geolocation, which is just a browser API, and it's usually derived from the Wi-Fi which your laptop can see. So it's not very precise, and if the Wi-Fi can't be seen, it can be computed by maybe IP address, but this is even less precise. Some other interesting things about raster tiles, that in layers you can easily add some overlays, which is, for example, nodes, or also even PNGs which are transparent, so we can add the touristic roads of Czech Republic just as a layer. Yeah. You can get the idea. And since it's also OpenStreetMap, you can also do some funny things like crayons or this. Okay, let's go back. And now, why I am showing this site? Because it has Mapbox GL, as you can see from the logo, and this has a vector tile. So what's the difference? With vector tiles, as Vladimir already said, is all the lines and all the features are encoded in a binary file, which can be zoomed in any extent. And otherwise, if you use raster tiles, it just pixelize. So it's very different, and also it has some challenges. And if there wasn't Mapbox GL, it wouldn't be very easy to do it. For the reference, Google Maps API provides only raster tiles, as far as I know. But on the main website, you can see that they use the vector tiles. You can see that when I'm zooming very quickly, it's still, until the data loads, the streets are still visible. And also, everything is clickable. Well, you get the reason. I think there was also some option to tilt the view a little, but I'm not sure where is it now. Okay, as you have heard, it's browser rendered. It's using WebGL and MapboxGL, but there are some other libraries, and it could be also rendered by SVG, which is of course very slow, but we have one very good use case for it, and this is the ID editor, which is used for editing OpenStreetMap, and I will show you this later. It uses vector data, so you can use the Mapbox vector tile or the XML directly, which is the raw data from OpenStreetMap platform, or any GeoJSON, which is kind of standard for web cartography now. It's clickable, it has overlays as well. And I can show you another demo, which is this 3D style. I think Vladimir already showed some better examples, but this one is using different API than Mapbox. It's coming from OpenMap tiles, which is based from the company Klokan, which is Czech, I think, or was Czech. And as you can see, the data can be displayed very interestingly. All this data comes from OpenStreetMap as well, but the renderer is Mapbox GL with a specific style, which is also open source. Okay, let's go on. So, to deploy a Slippy map, you need tiles and JavaScript library. For Google Maps, we have Google Maps API for tiles, which is the priced or paid solution, and the framework, which is usually free and sometimes even open source. On OSM-based tiles, you can use different providers and different libraries to display the data. Also, there are some other providers which have usually their own proprietary JavaScript libraries, but there is a good thing that those which uses raster data usually use Web Mercator projection, so you can combine them very easily. You can just take one URL from one platform and paste it into another. The bad news is that if you do it, you usually violate their terms of use. So sometimes it's not really easy. As you can see, also these vector providers can work with Mapbox GL or Tangram, which is also project by Mapbox, but I think it's discontinued now, isn't it? Different company. Ah, okay. Mapzen. Yeah, it was Mapzen. Fine. So now we speak about the pricing. This is the new pricing, I believe. Google charges you for $7 for 1,000 of map loads, which is like every user which loads the map. All the other providers are charging for loaded tiles, or as they call it, transactions, which covers like 10 to 15 tiles. So if you have like 100 users per day, you can be charged like $35 per month. But if you are a bigger company, this easily goes into thousands. Apple Maps is also doing their own platform because they own their own data, but it's still in beta and it's in non-commercial use. The map on OpenStreetMap.org has their own tiles, which are kinds of free to use, but in the terms of use, there is written that it shouldn't be used in apps and with no heavy usage, so just for freelancing purposes. I will come back to Mapy.cz later in next section. So, can we have some free maps now? We can. We have OpenStreetMap, which should be free, right? It's like free beer or free data. So, the basic misconception about OpenStreetMap is that people usually think that it's the map they find on this website, OpenStreetMap.org. There is one specific renderer, one specific kind of uglier map, and people say just, oh, I don't like OpenStreetMap, it doesn't look very good. But in fact, OpenStreetMap is just the database, just the data, just the vector DB, and you can render it into different use cases and also different apps. Can you raise hands, perhaps, who are using any of these apps? Well, like maybe all of you tried some of those. OpenStreetMap is basically on loads of websites as well, usually through some other providers like Mapbox, or well, there are some other ones I will show you later. Also, you can render the map into some vector navigations. So, if anybody remembers the Garmin devices, it can be also like transformed to the file which is to be used in the Garmin device. Okay, as you can see, it has lots of active users every month. This is like in the floating time of 30 days, how many people edited the map. So it's like in 40,000, and the data gets much better. If you compare it with some other data sources, you can see that you can use OpenStreetMap freely, also for printed solutions, usually in free licenses, but it can be broken. Some areas are missing, and but otherwise, some areas like cities like Prague are overmapped, so you can see like benches in park, trees, and trash cans. So it's really crazy sometimes. But that's the thing about OpenStreetMap, that it goes from just fairly mapped, just roads, then it evolves to like good mapping, kind of, and then in some areas it evolves into crazy mapping level. For proprietary maps, it's as you can read, it's very useful for emergency services because they can't afford to not find a village, for example. Well, these are the free providers for OpenStreetMap, but all are limited by some limits. You have to ask for API key, and your application will be free only if it's like under this limit. As I have found today, Mapy.cz, they are free even for commercial usage, but if I'm not mistaken, they don't allow the usage of tiles in different applications than their own. So they have their own Maps SDK for JavaScript. I'm not sure if they have for mobile. Maybe Honza will tell you later. And also there is one asterisk, one note, that Mapy.cz uses OpenStreetMap in all around the world, but not in Czech Republic and not in Slovakia, so just for you to know. Okay, and we also have the hard way, just for you to know, because it's also possible to do it the hard way. We have the planet.openstreetmap.org, which has 1 terabyte of raw XML data, and you can download it very easily. Yeah, I haven't done it yet. You can download it also in gzip. I think you can't download it in the raw XML anymore, but it was possible before. And also in the protobuf format, which is the very same format which is used for Mapbox tiles, but it has some different schema. You can also find country extracts, so if you just want to render Czech Republic or any other country, you can find it. You can find extracts for cities, but I think they are not working right now. And also we have this Overpass API, which is a service which can download well, smaller amount of data, but based on any query. So you can ask, for example, for all buildings in Prague, or all buildings which are higher than something, or all pubs in Prague as POIs, and you can turn it in GeoJSON and do some visualization on it. Well, if you want to render your own raster tiles, there's a website which tries to help, which is called Switch to OSM. This process is kind of complicated. I will just show you to see a hint. So if you want to build a tile server, you need to install many packages on some Ubuntu server, install Postgres, import all the data from the XML or protobuf format into the Postgres database, and then use some Python scripts and Mapnik library to render it into PNG. It kind of works. I did this tutorial many times, and sometimes it worked, sometimes it didn't. And I don't recommend doing it on your own. Maybe it's better to use Mapbox tiles, but it could be useful if you want to just statically render whole country up to zoom level 15, let's say, or 10. Maybe it's better because the size is exponential. And then you can just save it into some server and never update it. It's not very good because OpenStreetMap evolves every day, but for some use cases it could be fine. For example, I've seen this in the train, Railjet or something, that they have some map portal and they have rendered this from OpenStreetMap, and they forgot to mention the license. What a company. Okay, so there are some free Carto CSS templates which you can update, so you can do your very own styles and render it on your own. Also, you can use this Carto CSS for on some cloud solutions. So it's usually these solutions like Mapbox or Thunderstorm. They could be customized. And nowadays there is, thanks to Mapbox.gl, there is this provider which is called OpenMaptiles. This is the one by the Clocan company. And it uses vector tiles, so it's kind of easier to use. And especially they use Docker and Docker Compose. So it's very easy to set up. This is a quick comparison, which I ran a few years ago, I'm not sure, 1 or 2. And for Prague, it took 16 minutes and made 7 gigabytes of database. For the whole Republic, it was 1 hour and it was 25 gigabytes of the database data. So it's kind of reasonable to have this size of database on your server, but just be warned that this CPU or this server, virtual server, which I had on Amazon, was not enough to serve it very quickly. So if you want to serve this kind of database very quickly, you just maybe need a much more powerful machine. So it's, again, it's good to ask if you need live data, or if you are okay with pre-rendering the vector tiles. You can also pre-render vector tiles and serve it from some snapshot. I will just show you quickly OpenMap tiles. They have this openmaptiles.org, which is all their open source effort, and they have this .com, which is priced. I think the pricing is somewhere here. It's not very cheap. But they have created another service which is called Maptiler, and this has much better prices, I think. I'm not sure where the price is hidden. Can you see it? Cloud, yeah, it's cloud. But no prices. I will go back for it later. It was, it's free for up to 100,000 K of views, map views, and it's like a few dollars, I think, for some heavy usage. So what's the time? I think I have like 5 minutes, I would say. So let's see what we have next. Yeah, this is the last part of my presentation. Is about the APIs. So just a quick summary. There are these APIs like geocoding, which is if you have address or any other descriptor on Earth, and you want to turn it into coordinates in degrees. This is the VGS84 coordinates which are used usually. Or there is also a possibility to do reverse geocoding. So if you have coordinates, a point, and you need address, which is very useful to do it in batch, in this, like bigger data sets to know something about your users, for example, to know their address. Routing is also clear. You can have directions or maybe travel times. Also, there's possibility to ask for like transit metrics, so you can have several origins and several destinations and find all the possible routes between these points. So it's like traveling salesman, counted all the way. Elevation data. This is not connected to OpenStreetMap because elevation data is free by NASA. They have created this SRTM dataset, which has the elevation of the whole Earth. It is not very precise. Okay, is the central power of Earth. Okay, thank you. I think there are maybe other datasets which are not that precise, but they have almost the whole Earth. There are also this Aster GDEM model, which is kind of more precise. You can find it easily, but many services like Google offers their own elevation API. I'm not sure about Mapbox. Yeah, you can find it. Location by IP address. This is also different service because you have to have your own database with IP addresses and their specific places. So this is usually not connected with map services, but it's useful to have it. The precise geolocation is just a browser API, as we have talked before, and this is on mobile. It's usually very precise because you have Android with Google Play services or iOS with similar services, which have collected a large amount of Wi-Fi SSIDs and Bluetooth SSIDs, and all these together helps you geocode your position. So it also works indoor, for example. You should try it sometimes, and if you switch off Wi-Fi and Bluetooth, it maybe get worse. GPS, of course, is another means of geolocation, but this is not connected with OpenStreetMap because OpenStreetMap offers their own elevation API. So it needs internet connection to get the position of satellites, otherwise it takes up to 10 minutes to compute it. And also it works only in like areas with good sight of the sky. One interesting API which I would like to show you in the end, because we don't have much more time, is Static Maps API. I have Googled for it before, but let's see. It's this one. In several services have their own static maps generation tool, and for example, here you can move this Slippy map, this standard map, and we should place here our token. You remember your token? Oh yeah, you're lucky. It creates a URL similar to this one. It can be, of course, generated programmatically. And if you click the button or create this URL on server, you can see it's a static image, one image, which is baked with all the information which you put inside it. So you can usually, maybe not here, but it's just kind of preview, but usually you can add some points of interest, some icons. It can, for the Google Maps static API, it can even load your own images and like render it into the map. It can also render routes, which are encoded into your URL, but you are limited by 8,000 limit of URL, 8,000 characters. Well, let's get back to the presentation. Yeah, I have some examples. Maybe I will share these examples with you just on GitHub or something. And maybe last thing I would like to show you is the ID editor, and we will end this presentation with it. So if you open OpenStreetMap.org, we can geolocate ourselves here. Let's see if we find the impact hub here. It should be somewhere around. And if you are logged in, you can hit the edit button and OpenStreetMap editor ID loads here. Very interesting thing about this editor is that it loads the data in XML, and it uses the D3.js library and renders it into SVG. So this is all rendered by DOM, D-O-M, and this blinking is by CSS, and as you can see, here is our impact hub. So you can also see some properties of this points of interest, that it's a amenity co-working space, and it has a name. It doesn't have any address or anything more. So if there is some of you is an editor of OpenStreetMap, you can add these into the database. So this is all I wanted to tell you today. I would like to hear your questions if there are any. If not, you can ask me later on any of those websites. And thank you.